Okay, so if we draw the line y equals x, okay, well of course we know what that looks like. It is a 45-degree line, okay, that goes through the origin. But quite simply, whatever x is, y will be the same. So if x is 2, y will also be 2. Okay, in this case they're saying show that there's only one solution of x for when y is equal to 3. So if y is equal to 3, say there, okay, then we can see that there is only one solution. And if we draw a line across where it hits the line, there's only one solution. Clearly we know that's going to be 3, yeah? So there is only one solution. And x will equal to 3. Okay, pretty obvious, yeah? Now, we're going to start looking at the modulus function. Okay, and the modulus function is denoted by those bars there. Okay, that just means the modulus of x. What that means is that it makes everything positive. Okay, so if we look at the graph of y equals x, okay, here we've got positive parts, we've also got negative parts. So what this does, what these bars do, is that they make everything positive. They make sure that everything is positive. Now, these values here of y are already positive, aren't they? Yeah, they're already positive, so nothing's going to happen to these. Okay, in fact, I can just draw the same graph again. For the positive part of that graph. Okay, we've got positive y values, so it is nothing needs to be changed because they are positive. But as I said, what the modulus function does is it makes everything positive. So these negative values here will suddenly become positive. So when y is, say, -1, okay, well, it'll make it into positive 1. When y is -2, it'll make it into positive 2. When y is -3, it'll make it to positive 3. So it flips the sign, okay? It makes negative into positive. So as well as flipping the sign, it's going to flip the graph. It's going to actually reflect it in the x-axis. So what you're going to have then is that negative part literally reflected in the x-axis. And that will be your modulus of x, okay? So you've already got your positive values, but the negative values down here, they suddenly become positive. They're made positive. So if you've got -4, it becomes +4 and goes up here. Okay. If you've got -5, it becomes +5 up here. If you've got -6 for the y value, it becomes +6 up here. If you've got -7, it becomes +7. If you've got -100, whatever down here, it'll become +100. So it flips in the x-axis, and you get that. Okay. That will be the modulus graph for x. So then it says, show that there's two values of x for y equals 3. Well, if I go to y equals 3, like just as we did before, and this time you can see, of course, yes, there are going to be two values because we've not only got one here, which of course is 3, because when x is 3, y is 3, but we've also got one here. Okay, so you can have a kind of guess what that one's going to be. Obviously, there's symmetry there. So we're going to have -3, yeah? So two solutions. X equals to -3, or x equals to +3. Okay, so then it says here, by drawing the graph of y equals x plus 1, draw the graph of y equals the modulus of x plus 1, and find the two values of x for when y equals 1. Now, y equals x plus 1, if you think about the graph y equals x, okay, well, if it's y equals x plus 1, it's literally just shifted up by 1, yeah? So it'll be parallel to this. It's got the same gradient, okay? Because you still got like the x bit at the start, okay? It's like 1x, isn't it? The start, like you've got here, but it's +1, so it's the same gradient but shifted up 1, so it'll be parallel to it. But it'll be kind of like shifted up 1. It's going to look a bit like this. There's your y equals x plus 1. Now, if you make it so that if you're going to draw the modulus of x plus 1, this bit is positive, isn't it? So that bit will stay this positive, it'll stay there. But the negative bit, okay, when you put the modulus around it, makes it positive. So when it's, say for instance, I don't know, say minus 10 down here, it'll become positive 10. So this bit here will reflect in the x-axis, okay? It'll flip in that x-axis. So what we're going to do, we're going to be careful when we sketch this, to sketch the positive bit exactly as it was, okay? But then we're going to reflect the negative bit in the x-axis. So it kind of looks a bit like that, okay? So you've got the y equals x plus 1 there. So this bit remains as it is, because it's already positive, but the negative bit reflects in the x-axis, so this will be the modulus of x plus 1. So then it says, find the solutions when y equals 1. That's what it says in the question. Okay, well, when y equals 1, if I go back to this graph, y equals 1 is literally here, isn't it? Okay, because if you look at that, yeah, y will equal 1 when x is 0, yeah? Okay, so there's one solution here, but when we do the modulus of it, we're going to have two solutions, okay? So if you want, you can draw a line across just here, and y equals 1. You can see there's two solutions. So we've got this solution here, which we know x is going to be 0, yeah? Which we discussed up there, and you're also going to have this solution there, okay? Now I know because of the symmetry of this, okay, because of the actual graph y equals x plus 1, this here is going to be negative 1, okay, just because of the gradient of it, okay. For every 1 you go across, you go up 1, okay, right. So this would be minus 1 here. For every 1 you go across, you go up 1, and the same goes there. When you go back 1 to minus 2, you end up going down to negative 1, because you're going back 1, you're down 1. That's how the gradient of this works. So when you reflect this, when you reflect that minus 1, it becomes positive 1 here. So it will relate to that value, minus 2. Okay? So we've got x equals 0 as a solution, or x equals minus 2. Okay? Now, in the next few videos, we're going to see a much quicker way of working out the solutions to this. So in this case, we've worked out the solutions for the modulus of x plus 1 when it's equal to 1. Okay? When it's equal to 1 there, that's what we've actually solved. We've solved this. Okay, we've solved when the modulus of x plus 1 is equal to 1, and we've got two solutions. We're going to find in the next few videos a much quicker way of doing it without having to draw graphs.